Okay, so the next one says find the vertices and foci of this. This is a hyperbola, so we're going to have to look at the hyperbola formulas in the formula sheet now. Now hyperbolas are a little bit different. When the x term comes first, we are looking specifically at the left column here. So when the x terms come first, that means the focal axis is horizontal, so that means the hyperbola opens this way when the x term comes first. And when the y term comes first, it's going to open vertically. Okay, so we're looking at this column right here. We know that. So we have our formula, and we know then by comparing that h is 2 and k is 1. So here's our hk, or our center. I like to graph these just because I think it really helps like visualize it. You don't necessarily have to graph it, but the center is at 2, 1, which is right here. Now, if you look at this, I would write this in a different form. So I'd write it as x minus 2 squared over 16 minus y minus 1 squared over 64, just because I'm used to writing it like that. And then a is 4, and b is underneath y in this case, which is 8. So what that means in terms of graphing a hyperbola is you go over 4 to the right, so 1, 2, 3, 4, and you put your first vertice, and you go over 4 to the left, 1, 2, 3, 4, and put your other vertice. And then if you go up 8 from here, so you go up 8 to this point and down 8 to this point, and you make a box, and then you graph the corners of the box will be lines, and those are asymptotes. Those are your asymptotes that are actually right here in the last row. And so then you can draw your hyperbola like this. It goes through these vertices and goes. It's an asymptote, and these are the asymptotes. Okay, so when it wants us to find the foci and the vertices, we're looking at this part right here. The foci are at h plus or minus c comma k. So in this case, our h is 2. So we have 2 plus or minus c comma 1. So we need to find c. Now c comes from right here. C, we have a Pythagorean relation for these, which is that c squared, the relationship between a, b, and c is c squared equals a squared plus b squared in this case. So we have a squared is 16, b squared is 64. So that gives you c equals the square root of 80. So if we do plus or minus the square root of 80, that'll give us the foci. Now, it wants the small one first, so make sure when you enter these in, you do 2 minus the square root of 80, comma 1 first, and then you do 2 plus the square root of 80 second. Okay? And then it also wants us to find the vertices. So to find the vertices, you do h plus or minus a, comma k. So these are a little bit easier. You have h plus or minus a is 4, comma 1, comma k. So that'd be 2 plus or minus 4, comma 1, which do the small one first, so do negative 2, comma 1 first, which is this point here. And then do 6, comma 1, which is this point there, in that order. Okay, the next problem gives us standard form for a hyperbola. We know it's a hyperbola because it's got a minus sign here. And it tells us the center, hk, of this hyperbola, and it tells us the focus is at this point, one of the foci is at this point. And it also tells us one of the vertices. So I would always graph these because I feel like it really helps to look at a picture. And it helps organize the information. We know our brains are visual, so graph it if you can. 1, 2, 3, 4, 5, 6, 1, 2. So here's the center. And then one of the focuses at 11, 2. So here's 6, 7, 8, 9, 10, 11, 2. And then another one then, says the vertex is at 2, 2. So if one of the foci is at 11, 2, it turns out that this distance between the center and this focus right here is 5, from 6 to 11. So go back 5, 1, 2, 3, 4, 5, and put another foci. And then put the vertices, so one of them is at 2, 2, which is right here. So it turns out the vertice is 1 unit back from the foci, one of the foci, so put the vertice here. So we know what this hyperbola looks like. It looks something like this now. And that can help us. So from here, they want us to fill out the formula. So it's x minus 6 squared over a. Now a is the distance from the center to one of the vertices, which in this case is 1, 2, 3, 4. So a is 4. And then it's y minus k is 2. And b now, we don't know b. B is actually the distance right here to to the top of a box we're going to make later to graph these. But we don't know what that is, so we're going to find it using this Pythagorean relation right here on the formula sheet. That Pythagorean relation is c squared equals a squared plus b squared. We actually know c. C is the distance from the center to the focal point. So that's, we said that was 5. So 5 squared is 25. We know a is 4, so that'd be 16 equals b squared. So if we subtract 16, we get 9, and that makes b equal to 3. And so now we can fill this out. I wish they would use h for the c, but so not to confuse it with the c that is, the actual distance here. But they used it here, so c in this case is 6, a is 4, d is 2, and b is 3. Okay, the next problem here wants us to indicate each of these, whether they're a line, a circle, an ellipse, but not a circle, a parabola, or a hyperbola. So basically, we know the formulas for these. These are all on our formula sheets. Here's parabolas. Parabolas have one variable squared, but not the other. Here they have that pattern. Ellipses have both variables squared, and you have a plus sign in between, and you have different numbers being divided by x and y. So if you have the same number, it's actually going to be a circle. But if the numbers here are different, then it's going to be an ellipse. A circle is just one specific form of ellipse where a equals b here. And then you have hyperbolas where you have a minus sign in between x and y, and they're both squared. So keep that in mind when you go through these. So the first one has a plus sign here, and we have different numbers underneath x and y, so that means it's an ellipse, not a circle. This one has both squared, we have a minus sign, so that's got to be a hyperbola. This one has just x to the first and y to the first. We know it's a line. In fact, that's a line in standard form, what we called standard form. This one has x squared and y squared. It's a plus sign, but you have you're dividing. Actually, if you put this in standard form, you have x minus 1, standard form for an ellipse anyway, divided by 4 plus y minus 3 squared divided by 4 equals 1. So you have the same thing underneath x and y, which means it's a circle. And you might recognize that it's in standard form for a circle. And then this one has just x squared but not y, so we know it's a parabola. Okay, the next problem is similar. It wants us to do the same thing. Tell whether it's a line, a circle, an ellipse, a parabola, or hyperbola. Okay, the first one here, I know it says, I'm not going to ask you to go through, and solve these and put them in standard form, but if you did, you'd move the 1 over, and then you divide by 2. So this would be x squared over 1, y squared over 2. Basically, you can see is that you have different things underneath x and y, so that's going to be an ellipse. Okay. The next one, you can see that this is a line. You got first power here, so use an L for a line. The next one has x squared but not y, so that's a parabola. Now the next one's tricky because you have to actually complete the square in both of these. Now, because you have x squared and y squared, it's either going to be an ellipse or a hyperbola or a circle. Now, there's no minus sign, so I don't think it's a hyperbola, so I would try circle and ellipse. Turns out that circle works for mine. It just kind of depends on what you end up dividing by x and y when you put it in standard form, if they're the same or different, because a circle really is an ellipse. But it turns out that this one's a circle, a special form of an ellipse. And the next one has a minus sign here, so you're going to end up with a hyperbola when you do put it in standard form. The next problem is a really tough one. It wants us to put this in standard form and then determine the distance between the vertices. So to put this in standard form, I'm going to write negative 9x squared plus 18x, and I'm going to leave a space here. And then I'm going to do 4y squared plus 24y, and I'm going to move the 9 over to the other side, so equals positive 9. I'm going to leave a space here, because I'm going to have to complete the square on both of these. Before I do that, I'm going to pull out a negative 9 in front here. That would leave me with x squared plus 2, or I'm sorry, minus 2, x plus some kind of space. And then I'm going to factor out a negative 4 from the next one, which would leave me with y squared minus 6y plus space equals 9. The reason I left spaces is because now I'm going to complete the square. So I'm going to add b over 2 squared to both sides to make it a perfect square trinomial. So b over 2 in this case is negative 2 over 2, which makes negative 1 squared, which is really just 1. And 1 times negative 9 is a negative 9. So I'm going to have to subtract 9 from the other side as well. That's really what I'm doing when I add 1 right here. And then here, b over 2 would be negative 6 over 2, which is really negative 3 squared, which is really just 9. I'm going to leave it as negative 3 squared right here. But then keep in mind it's really 9, and 9 times negative 4 is a negative 36, so I need to subtract 36 as well here. That leaves me with negative 9 times x minus 1 squared. This is a perfect square trinomial, so put x and negative 1 here. Minus 4 times y minus 3 squared equals, these cancel and you end up with negative 36. Now I need this in standard form, so it looks like a hyperbola so far. I'm going to divide by negative 36 though, from everything, to get this to be 1. And it might be an ellipse then if these negatives cancel. So double negatives cancel here and also here. So I end up with, let me simplify this, 9 goes into 36 4 times and 4 goes into 36 9 times. So I end up with x minus 1 squared over 4 plus y minus 3 squared over 9. So this is an ellipse, not a hyperbola. And we need to find the distance between the vertices. So we need to just quickly graph this thing. For an ellipse, this one's centered at 1, 3. So I'm going to go over 1, up 1, 2, 3, which is right here. Now, the bigger number a is underneath y in this case. So typically on the formula sheet, we would write for ellipses, when the bigger number is underneath y, we usually write that first, y first, like that. But a is linked to the semi-major axis, so a in this case is 3. So we would go up 1, 2, 3 for that length, and down 1, 2, 3 up to here. So there's the distance between the vertices, which in this case is 6. All right, the next problem says we have a hyperbola has a vertical transverse axis of length 8, which I think that's a typo 2. This problem has a couple problems in it. For me, this didn't work, the focal length, but I'll go through it anyway. These first and third answers should work fine. But they gave us two of the asymptotes, and they want us to find the center and the focal length and then the eccentricity. So I'm going to graph both these lines real quick, and I'll let you look at that graph then. Okay, so I've got these two asymptotes graphed right here. Try to graph them as good as I can so that I can draw this clearly for you. But it says that it's a vertical transverse axis. So that means that the parabola is going to go through some point up here and go vertical. The asymptotes are here. So something like this. We can find the center just by finding the intersection of these two lines. That's pretty easy. So just set these two equal to one another and solve. Now, unfortunately, I get a really ugly number here, a fraction, which I know we're not comfortable with fractions, but that's okay. It's good practice. So we're going to add 7 over 3 to both sides. It gives 14 over 3x equals, add 4 to both sides. It gives 13. Multiply both sides by 3 over 14 to get rid of this, and you get x equals 39 over 14. That's the x-coordinate. That's h, the x-coordinate for the vertex. To find the y-coordinate, I plug this back into either one of these and find out what y is. So I'll do that now, which is 7 over 3 times 39 over 14 minus 4. 3 goes into 39 3 times. 7 goes into this twice, so it's 3 halves minus 4. So 3 halves minus 4 over 1. I'll make the common denominator 2, which makes this 8. So negative 5 halves. So my center is at 39 over 14, comma negative 5 over 2. That works fine right here. Okay, so they want us to find the focal length. Now finding the focal length is pretty tricky. It's actually the distance from the center to one of the foci, but double that, because the focal length is the whole thing. So we have to find basically that distance from the center to the foci, which is c. And we can find c by using the information that's on here. I'm going to use this right here. You know, we're talking about this column where x equals number. We're talking about a vertical hyperbola. So we're over here.